Okay, good morning, everybody. Let's get started. Could you see my screen?
Yes.
Okay. You see the information on midterm exam 1 to be held on September 21st. This means on coming Monday. Uh, the exam duration, although I mentioned here like usual class time like 9:10 a.m. to 10:05 a.m., but I like to allow long time because you need to scan and then finally you need to upload on the Dropbox. So what I am going to do, I am allowing you 3 hours. You can start exam exactly at 9. I will make the exam paper available on eCourseware. So on the content page, I will create a tab like exams. And then if you click there, you can see midterm exam 1 questions, and then you start writing answer on your own paper, white paper, and then at the end you all need to scan and then make a PDF file and then upload on Dropbox. I will create a Dropbox as well, and I will notify you beforehand. So I am going to allow you 3 hours, 9 to 12. 12 is the last time for submission, and then I will be asking you like only 4 to 5 numerical problems, similar problems that you solved in the homework 1 and homework 2. And currently, we are discussing the power calculation, this type of similar problem. So, if you can answer well, then I think it would not take more than 1 hour. I think 1 hour is fine, but I am allowing you 3 hours so that there might be some internet issue. You can first download that question and then later you can upload properly one time. That's why I will allow you 3 hours. And then also I know that some of you may have class right after 10. So that is the other reason. So you attend your next class, but still I am allowing you another 1 hour, like 11 to 12. So 12 is the deadline to upload the scanned PDF paper on the Dropbox. So I think 3 hours will be fine, right, everybody?
Yes.
That'd be great.
Yeah, yeah, yes, yes. No, I know, I understand your situation. Um, I mean, typically when I take the exam in person, then I just allow 1 hour. I mean, usual class time. But because you all are working remotely, so I understand there might be internet issue or some other issue. Sometime in internet slow, you're not able to upload. That's why I'm allowing you long time. Whenever you are done, you just upload. That's all. Okay, and then as a syllabus, you have to look all class lectures starting from 2. 2 means, first class or just introductory class. I really did not cover any uh, technical things. So you have to look 2 on through 14. 14 means, I mean, Friday's class, day after tomorrow's class. Today it is 13, number 13. So we will be covering something in next class as well. So that's the syllabus. That is the meaning. So you will be looking 2 through 14. So I mean, three things. You know that I upload the class notes that as class lecture, and then you all attend the class. Right now you are attending, you are listening, and you know that later I upload the video. So therefore, these are all the resources. You all will be looking all numerical problems that I have discussed in the class and your homework. And then today I'll be doing something and next class. You just follow all of those things and you all properly understand. Then you will be fully fine on the exam. And then if you want to look the book, then in terms of book chapters, we have covered chapter 9, chapter 10, and currently, I am working on chapter 11. So just 3 chapters will be fine, 9, 10, and 11. But mainly you follow the class lectures, what I covered. Exactly you understand those things and you will be facing similar problems in the midterm exam. Okay. And then although I cannot see you that how you are working, so I cannot see you. But everybody, please be honest as possible, and then don't contact with others. You do yourself, solve problems yourself. Each of you are allowed one or two piece of paper writing down any important equation. For example, overdamped, underdamped, critically damped. You can write down those equations in one or two pieces of paper, equation only. And during exam, you can look those cheat sheet or those two sets, yeah, just to look the equations. You are not allowed to draw on a circuit diagram or solution. Just to look. Okay, so is everybody fine?
Yes, thank you.
Okay, yeah, great. Uh, okay, now moving forward, everybody see, we were doing this numerical problem, but I think I could not start. We were ran out of time. So once again, everybody read this one, and then I am going to the solution directly. A 25 kilowatt, 11 kV, 60 hertz industrial load with a power factor of 0.5 is being provided by a single phase power source. Is it possible to increase the load power factor to 0.9? If so, is it by using an inductor or a capacitor? And also calculate the inductance or capacitance value required to make the load to the desired power factor. So this means that, initially the power factor was 0.5 for that industrial load. And later it is being increased, upgraded to 0.9. So therefore, maybe you remember in the previous class I discussed that it is possible to increase the power factor with the help of a capacitor. So therefore answer is yes. I have written here, yes, it is possible to increase the load power factor by using a capacitor. Now I am asking, if so, calculate the inductance or capacitance value required to make the load to the desired power factor. Now if it is yes, so what is the value of capacitance in farad or microfarad? For example, here I got the result, capacitance value 0.684 microfarad. Now I will be looking how that is possible. So therefore, everybody see that solution. Let me make it bigger. Okay, here you go. Okay, so for this type of problem, what I would recommend you, everybody, first you draw power triangle. You see, like previous two classes, I think I drew this type of triangle. Your very first task is draw a power triangle. Like first look this on this phi, then this is Q, reactive power, and this is that S, apparent power. And first you see, I got this angle, which I have designed theta old. Old mean the original value, previous value. Okay. And then later you see, I reduce the Q. Originally, this is the full length of the Q old. But as I inserted the capacitor is reducing the reactive power. You see, that's why I am assuming that this amount is the reactive power provided by the capacitor. So therefore, I got the new triangle, which is this one. You see, the small triangle. Now, with respect to small triangle, this is the new theta. So that's why this portion is new theta. So therefore, everybody, with respect to big triangle, this is the theta. That is the theta old, and this is theta new. Similarly, for the small triangle, this portion I have designated Q new value of reactive power. Now, the question was, I mean, everybody see, the question was calculate the inductance capacitance value. You have to find out what is the amount of capacitance. But this axis, y-axis, is that reactive power. So first we have to find out how much reactive power is being provided by the capacitor. Once you can know that, then later you see that I have used the equation Q cap mean or reactive power provided by capacitor, that is Vc over Xa. Later we can apply this equation and ultimately I got the capacitance value. I am coming that point. But the first thing is that everybody look, this will be your approach, Q cap. So I think just a moment. I think I have what is on the top. Let me, okay. So, sorry. So therefore, everybody see what is the Q cap value? Q cap value is, you see, so what I have done, Q cap is this keyword value minus Q nu value. So this means with the help of this triangle, you have to find out this keyword, what is the amount of that keyword, and what is the amount of your Q nu. So this means if you can know this amount, and if you subtract this one, then you will be getting this one, Q cap. So that how to do that? So everybody see this one, what I have written, look the big triangle, keyword over phi. That is the tangent theta word. You know, from trigonometry, this perpendicular over base, this means that is the tangent theta. But this is tangent theta word. You have to look the larger angle. Now, this means that from this equation, Q word is phi multiplied by tan theta word. So you see, phi multiplied by tan theta word. Now, what was your P value? P value was 25 kilowatt, which was the load value, you see, at the beginning, 25 kilowatt industrial load. So that is my P value. That is the real power or active power. Now you have to get the tangent theta word value. If you get, then you are done. So how I am getting? Look here, cos theta word 0.5. So what is that one? In the problem, look, the with a power factor of 0.5 is being provided by a single phase power source. This means my original or the old power factor value is 0.5. But you know, power factor means cosine of theta. Power factor means the cosine of theta. That's why everybody see, I have written down cosine of theta word is 0.5. So therefore from there what you do, you calculate tan theta word. So I got 1.732. So this means you will find the theta and then you make it tangent theta, 1.732. So then I am done. So my phi value, now come back this equation, keyword, phi tangent theta word, phi value that 25 kilowatt and tangent theta word this one, 1.732. Then I got 43.3 kilovar. I got this one. Now I have to find out this amount. What is this amount with respect to new triangle? So therefore again, if I can know what is the theta nu, then I am able to find out. Now everybody see what I have written here, cosine theta nu. So cosine theta nu is 0.9. So this means this one, to increase the load power factor to 0.9. Power factor got improved, power factor got raised to 0.9. That is my new power factor. So that's why I am writing, everybody see here, cosine theta nu 0.9. Then again find its tangent theta nu. So with respect to this one, tangent theta nu is 0.484. And then why I did that? Your goal is to find out this one, this amount, theta nu. So again I am applying that thing, theta nu over phi is tangent theta nu. So this means Q nu, I have written Q nu is P multiplied by tangent theta nu. So therefore, P value is the same value, 25, and tangent theta nu, cos theta nu is 0.9. Accordingly, tangent theta is this value. I am plugging this number there. So I got 12.11 kilovar. So therefore, now I got both this one. I got both keyword. This keyword value is this one, 43.3, and I got Q nu. So just subtract this one from here. So if I do, I subtracted here Q cap, this portion is 31.19 kilovar. So that is the reactive power provided by the capacitor. That's why I got this new triangle. That is the meaning. And now everybody say, once I got that Q value, Q means reactive power of capacitor. So now come back. What I am writing? If you have a capacitor and if you know what's the voltage across it, then easily you can find out the reactive power. So reactive power is V square over X. Like for example, if it is resistor, then phi equal to V square over R. Similarly, Q cap is Vc square over Xa. What is my voltage? Voltage was given. Look the problem, 11 kV. 25 kilowatt, 11 kV, 60 hertz industrial load. This means that is the my system voltage, 11 kV. So that's why what I am doing, Q cap is that value, this amount, and that is the Vc square over Xa. And I am finding Xa, Vc square over Q cap, 11 kV squared. Finally, I got this one. And then what is the Xc? Everybody look, Xc means 1 over omega c, mean 1 over 2 pi fc. This is this one. From there, finally, you calculate the value of c. Then finally, I got farad. I converted into microfarad, 0.684. So this means this was my question. That was the question. They calculate the inductance or capacitance value required to make the load to the desired power factor. This means this value of capacitor can make the power factor to 0.9. Initially it was 0.5, it improved to 0.9. So everybody, could you follow me?
I'm having a little trouble hearing you. Like I have my volume turned up the entire way, but
okay. So which portion should I repeat?
it's fine. I mean, if you could probably just speak a little louder or move the mic closer, maybe that would help me.
Oh, okay. Sorry, yeah. Let me. Okay. So first, did you understand this triangle? I drew that one. So
yes.
first, this is the power triangle. So
right, with apparent power and true power.
Yeah. So this is the real power and this is the reactive power. So look, this big triangle, original triangle, this is P25 and this is the Q old. Q old means with respect to the original power factor. So which was this one here? Cosine theta old is 0.5. So cosine theta means the original power factor or old power factor 0.5. And then the question was that how much capacitance is needed to improve the power factor from 0.5 to 0.9. So that's why I have drawn another triangle, you see. I am assuming that capacitor is reducing the magnitude, this amount. This is the capacitor provided reactive power. That is making my new triangle. So this is theta nu. So now I am just applying the trigonometry. You just need to find out what is this amount, what was the original reactive power, and what is the new reactive power, this amount. And then if you just subtract this amount from this one, then you are getting this amount, right? Yeah. So could you follow me?
Yes.
Okay. And then see the rest of the calculation. You need to find out this one. So what I have written here, you see, keyword over P, that is the tangent theta. You all know from trigonometry. This is perpendicular, this is base. So perpendicular over base is tangent theta, but tangent theta old. Because I am considering this one, so you have to look this big triangle, original triangle. And then how you will be getting the tangent theta old? From here. Cosine theta old is 0.5. That is the initial power factor. So from there, I am finding tangent theta. Therefore, in your calculator, first you find out what is theta and then make its tangent. That will give you 1.732. So therefore, in this equation, plug in that number, tangent theta over here. You know the phi value 25 kilowatt. So you are getting Q watt, this magnitude. That is here 43.3 kilowatt. And then next time, again apply the similar technique. You find out this amount, which is Q new reactive power factor. Because power factor got changed. So I am getting cos theta nu 0.9. So look this angle. You just look this triangle, small one. Then similarly, I am finding Q nu, that is the 12.11 kilowatt. And then I am just subtracting this one from here that I showed here. Then I am getting this amount here, Q cap, means the reactive power provided by capacitor. Does this make sense?
Yes.
Yeah. So everybody, does anybody have any questions here? Could you follow me what I am saying? Is there any question from anybody? Okay, and then once you understand this on Q cap, because your question is to find out the capacitance value, not just the reactive part. That's why I am writing this equation. Priscilla, can you understand this equation? Q is,
Yes.
yeah, yes. And then the rest of the calculation. Just by using this one, you find out the C value. That's all. So this means this amount of capacitor is needed to improve the power factor from 0.5 to 0.9. That is the meaning. So therefore, this problem, everybody see, this problem is very standard problem. I mean, highly likely that you will face this problem in your FE exam. Everybody keep in mind, in your FE exam, highly likely that you will see this problem. I mean, in the past, the students told me who participated in the FE exam, frequently they are asked this question. I mean, just the numbers are changed. Just numbers will be changed, but problem is the same. So therefore, everybody please try to understand this one. This is very, very standard problem. Therefore, typically from circuit, I mean, including both DC and AC circuit, about 10 questions will be asked in the FE exam. So among 10, this is one of the problem. Pretty standard problem. That's why, I mean, in fact, all of the problems that I have discussed with you, from each chapter, at least you will be seeing one problem in the FE exam. Very, very similar or almost the exact problem in the FE exam. So therefore, everybody please understand this one. And my strong recommendation for this type of problem, first you draw the power triangle and you plot which things are given and what you need to find out. This is called power triangle. So therefore, if the question is about increasing power factor or improving power factor, immediately you draw this type of power triangle and then you see what is given and what you need to know. And then just apply the trigonometry. That's all. That is the easiest way. That's why I must recommend you all, everybody, please try this methodology. And then, as I told you, definitely you will be getting one problem. I mean, for sure, in the FA exam. Everybody, please. Is this fine, everybody?
Yes.
Yeah. Please, once again, at your home, you say, this is very, very nice and important problem. Okay, now moving forward. So you see, here I have, although this is not directly a numerical problem, but I have asked one question. Everybody say, very nice. Consider a series RLC circuit with the AC input voltage. under what condition will the current be maximum in the circuit? So the question is, like, you have a series circuit and you have the AC input voltage, or whatever the amount is. What is the condition that will make the current maximum in the circuit? So therefore, let me take you to the whiteboard, then you will be getting that easily. Everybody see my whiteboard. For example, you have R, you have L, and you have a capacitor in the circuit. So this is your circuit, and then you have a voltage source. So assume that the voltage is V, this is R, this is L, this is C. So we are discussing that when the current will be maximum. So therefore, the first of all, everybody see, for this circuit, what is I? I is V over G. V over G. So and then what is the G for this circuit? G is the impedance. So everybody see, G is R plus J XL minus XC. Right? So this one. So you know. So therefore, now come back here. So this is the G amount, but I want to write it magnitude. I want to put the magnitude. So what will be the magnitude of G? So the magnitude of G is, you look, R square plus XL minus XC squared, right? Yeah. Everybody, could you follow me what I am doing? So because this
Yes.
is, yeah, right, this is the complex number. So just find out what is its magnitude. So magnitude is root over R square plus this one. So because let me draw this one. You see, this is R, and then this one is this portion. So just I am simply writing in that format, Jx, this is your Jx here, and then this is the theta angle or factor angle, this is your G, this amount. So this is the magnitude. So now everybody see, the question is, for this series circuit, what is the condition or when the current will be maximum? So therefore everybody see, because this is my current expression, V over the whatever the magnitude is, look the denominator. So when the denominator will be maximum, so if you can, everybody look, if you can make this portion 0, everybody say, if you can make this portion 0, so meaning that if you can make XL equal to XC, if it is, then what you are getting? You are just getting I equal to V over R. Right? So at that time your current will be maximum. But as long as there is some difference here, for example, XL is larger than XC or XC is larger than XL, always you will be getting some value here because there is squared. So your denominator will be larger. So you will be getting less current. But this is the maximum condition. This is the best condition. If you can make both inductive reactance and capacitive reactance equal, then this term vanishes. In other words, if you see this one, if you can make this amount 0, this portion, if XL, then it is your G equal to R. So therefore everybody say, if that is the case, that if this portion is 0, what is the meaning of this one? This means that your G will be fully superimposed on R. So therefore, everybody see, from this triangle, cosine theta, power factor. What is the power factor? This is power factor. Power factor is R over G, right? From this triangle, R over G. So this means that, as I said, that to get the maximum current, V over R, that is my maximum current, this portion should be 0. This means this portion will be 0. There will not be any value here. This means R and G will be equal. So your cos theta will be R over R, that will be 1. So meaning that the answer to that question for that series RLC circuit, current will be maximum when the power factor is 1. So, and power factor is 1 means that is the just fully the resistive circuit. These two will be cancelled because that is my assumption. So therefore, essentially circuit will be just a resistive circuit. Under that condition, current will be maximum because at that time power factor is 1. So therefore, just for example, a quiz. For example, I told you, okay, your V equal to 100 volt. Just take an example, V equal to 100 volt and R equal to 20 ohm. And for example, this is 2 Henry, this is 2 Farad, whatever, it does not matter. And I said you, okay, for this circuit, the power factor value is 1. I just said this one. Power factor value is 1. So everybody see what I am asking. I am saying that this is a series circuit. R value is 20 ohm, L value 2 Henry, C value 2 Farad, voltage value is 100 volt. Find out the current when the power factor is 1. So therefore, you don't need to do anything. You will be just seeing this information. Oh, power factor 1. Power factor 1 means circuit will be fully resistive because I already learned the theory cos theta is R over G. And when that is possible, when these two will be cancelled. So I don't need to do anything. I don't need to find the impedance. Power factor 1 means the current is maximum and then current is simply I equal to V over R. So therefore, even you don't need to calculator. The V is 100 and my R is 20. So I am getting, this is the 5 ampere. Yes. Everybody, could you follow me what I am saying?
Yes.
Yes.
So therefore, this is a quiz. This is magic or this is a quiz. So you may be worried that, oh, I have L value, so I should convert, I should calculate this. You don't need to calculate. You don't look whatever. If you see the power factor is 1, immediately take in your head, no, I don't need to do anything. Simply voltage divided by resistance. That is my current. And that is
the power factor, is this like an ideal thing that it doesn't exist?
no,
Power
no.
factor of 1?
And a power factor on, it is in real practice, it is difficult to make the power factor 1. Right, yeah. This is the ideal condition. So therefore, in reality, power factor goes very close to 1, like 0.98, 0.99. That is available in real practice. So this is the ideal condition. That's why the condition was that in the problem, under what condition the current will be maximum. So therefore, this is that condition if the power factor is 1. So now with respect to your comment and question that this is ideal, I am doing I equal to V over R. Does not this mean that this is the DC circuit, right? Everybody, I equal to V over R. This means just the DC circuit, right? DC circuit concept.
Right.
In everybody, see, in AC circuit, I am not writing I over V. I am writing I equal to V over G. You have to consider this on in AC circuit. But then ultimately, I started in that way, but I got conclusion that if these two become equal, my cosine theta is 1. then it is taking me to the DC circuit concept. That is the reason, like everybody, you come back to the DC circuit. Let me just delete this line. I mean, now you will get fun right now. Everybody see, in DC circuit, how you calculated the power? You just did V multiplied by I, right? But in AC circuit, we are learning VI cosine theta, real power. This is the real power expression. P equal to VRMS. Of course, these are RMS value. VRMS, IRMS, cosine of theta. Now see this one. In case of the DC circuit, your power factor value was 1. That's why you are not worried at all. You never ever think about the power factor, because always and always you had the power factor 1, because your circuit had only the R and R. Everybody remember, whatever you did, superposition, Thevenin, delta Y, transformation, series parallel, always and always. I mean, except the RL and RC transient, that is the different thing. Majority of the cases, your power factor value was 1. That's why you were not worried at all. You did not think. But essentially, this is the equation. At that time, your cos theta value was 1. And then just with the multiplication of voltage and current, you wrote the unit as watt, right? Everybody, just you multiplied voltage and current, you said that is the watt. But in this class, what we are saying, in this class, we are like saying that this is P, which is this one, that is in watt. And then this is Q, which is like Q equal to VI sine theta. You remember, so like in previous classes we discussed, Q equal to VI sine theta. That is your Q. And unit is var, reactive volt ampere. And this thing in hypotenuse we are telling which is the S, root over phi square plus Q square. The unit of the S is volt ampere. Its unit is volt ampere. Volt ampere. So which is just the multiplication of VI in both equations. So in AC circuit, everybody say, in AC circuit, the unit will be watt if you multiply the power factor. This means P equal to VI cosine theta. So without cosine theta, that is the apparent power. That is the apparent power. And unit of apparent power is volt ampere. Volt ampere. But in DC circuit, you did not say volt ampere, you directly say that is the watt, because you assume that your cos theta was 1. Now everybody is clear?
Sure.
Yes, everybody is fine? Yeah.
Yes.
Yeah. So therefore, I mean, as an electrical engineer, as an engineer, as I told you that, I mean, I already told few classes, but you have to remember this equation, phi equal to VI cos theta. P equal to VI cos theta. That is your real power or useful power. And Q equal to VI sine theta, which is this one. And as I said, this is of no use in real life. This is just inherently coming in the system. You cannot control anything. That is inherently coming from the system because of the presence of those reactive element, passive element. If there is only R in the circuit, never ever you will be getting the Q. That is the thing. So therefore Q is kind of extra or additional inherent power, internal power that we are not able to use in real life, but it is existing in the system. You cannot avoid it. And that is causing the problem in the power factor value. You see, this is my theta. When Q is 0, this means if you can make this thing 0, that time your power factor is 1. Or even though it is not on, if you can make it as close as possible to 1, that is the best thing. You have to, always your goal should be trying to avoid this Q, because it is useless. It just creates heating in the system. It just causes system loss. It does not help you anything. That's why in the problem that we discussed today, we use the capacitor to improve the power factor. So you see that was the problem, because the power factor is 0.5. 0.5 means there is significant amount of reactive power. Power factor improvement to 0.9 means I am eliminating the effect of the Q, reactive power, and capacitor is doing that. So therefore, in the FE exam, you will be asked that question, which element can improve the power factor? Your answer will be the capacitor. So therefore, that thing today we looked with this problem, that how it can be done. Okay, so then moving forward, I think now everybody understand, and quickly I will be solving two problems and then you will be done for today. Everybody see? Obtain the power factor and the apparent power of a single phase load whose impedance is G60 plus J40 when the applied voltage is Vt, this amount. So everybody say, two things are given. Impedance is given in that format and applied voltage is given in that format. So from this information, find out the power factor and the apparent power. That is the question. So therefore, everybody say, easily you can guess, because we have to find out the apparent power. I have the voltage expression. I also need the current expression, because apparent power is Vrms multiplied by Irms, but I is not here. So therefore, easily you can guess that you have to find out the I. And how you will get the power factor? From this expression, from the impedance. You see, this is in rectangular format. If you just convert into polar format, this expression, so you will be finding there is an angle, magnitude and angle. And that angle is actually the power factor angle. Just take its cosine theta. So therefore, see my solution, then easily you will get. Everybody say, G value was given, this one. I converted into polar form. So therefore, now this angle is, so for you I have drawn again that this is called impedance triangle. I mean, we discussed before power triangle. This is called impedance triangle. So therefore, R, X, and then this is J, and this is the theta. So therefore, here everybody see cosine theta is R over J, and this is the power factor. So meaning that you just need to look what angle is available with J. That's why the angle, what is my angle with J? 33.69. So everybody say I am calculating power factor cosine of that angle, cosine of that angle, because that is my definition, cosine theta. That is the power factor. So I got 0.832. Now, as I told you that we have to find out the apparent power, and apparent power is Vrms multiplied by Irms. So I have to get these two values first. So everybody see in the problem, this was given Vt on 60 cosine of this one. This expression was given. So from there, what you can write in phasor domain, V on 60 angle 10 degree. So then I got this one. So everybody see, I got V in phasor domain. I got impedance G in phasor domain, I mean in polar form. So what is my I? I is V over J, you know. So what is my V? This is my V. What is J? This amount is J. I plug in. I just divide this one by this. I got 2.22. This will go in the numerator. So minus 23.69. So then I got the I. The why I did the I? So this is the magnitude of I, amplitude of I, and this is the amplitude of V. I have to calculate the apparent power. So apparent power means Vrms multiplied by Irms. I don't need any angle here. So therefore, what is Vrms? This magnitude amount over root 2. Everybody see, we learned this relationship, effective value or RMS value, amplitude over root 2. What is my IRMS? This amount, 2.22, that over root 2. Finally, I got 177.6 unit is volt ampere. So I am done. Everybody, did you understand this one?
Yes.
Yes. Priscilla, could you follow me?
I think she might have had computer problems.
Oh, okay, I see. Yeah. Okay. So anybody has any question? Therefore, everybody please understand this one. I mean, you will be facing very similar questions in the upcoming midterm exam on Monday. Yeah. I mean, very similar thing. So that day you have to do properly. Okay, so I believe you will be looking again later. Then I have one more problem, and then you will be done for today. Everybody read this one. A single phase load G draws 12 kVA at a power factor of 0.856 lagging from a 120 volt RMS sinusoidal source. This means this is the kVA. kVA means that is the apparent power, load apparent power. Power factor value is given, cosine theta, this one. Voltage is given, RMS. So based on that, calculate number A, the average and reactive powers delivered to the load, and the peak current and the load impedance. So couple question. So first question is the average and reactive power. So you all know the average power and then the real power, that is the same thing. Keep in mind that average power and real power or active power, that is the same. And then reactive power, you know, that is the Q. And peak current means that is not the RMS value. Peak current means the amplitude of the current. Amplitude, not the RMS value. And the load impedance is J. So now everybody see the solution. First I have written S is 12 kVA because that value was given. This is 12 kVA. Then what I am writing? Power factor cosine theta 0.856. Directly that is given. This value, you see, power factor of this number that was given. So I wrote, from there, everybody look what I am doing. I am finding theta. I mean by cos inverse. You do in your calculator cos inverse. You will be getting theta. And from this theta, I also calculated sine theta. Sine of this angle that gave me 0.52. I mean, why I did that? Because I have to calculate the reactive power as well. Q. That's why I calculated this one ahead of time. Now everybody come back. So what you have to find out? You have to find out average and reactive power. So that's why once again you see I am drawing that power triangle for your clear understanding. This is P, this is Q, this is S apparent power, this is theta. Now look this on. From this triangle, I mean always we are discussing this thing. Cosine theta is P over S. P over S. From there, what is P? P equal to S multiplied by cos theta. And what is your S? S is that apparent power, this one, 12 kVA. So that's why I wrote in that format. So P equal to S cos theta. This P is your average or real power. That's why I am writing, everybody see here, average power Phi equal to S cosine of theta. S cosine theta. So S is 12 kVA and cosine theta value is this number, 0.856. So then you just multiply. I got 10.272 kilowatt. I expressed in kilowatt. You might express in watt, no problem, kilowatt. So one answer is done. What is the second one? Reactive power. Reactive power is K, S sine theta. Again, look this one. This is Q, this is S, this is theta. So sine theta is perpendicular over hypotenuse. So this means Q is S sine theta. Again, what is the S? The same thing, 12 kVA. What is my sine theta? This is my sine theta. That is the reason, you see, at the beginning, I also calculated sine theta because I know that I would need that on later. So substitute this number there. So 6.204 kilowatt. So that is the Q. Okay. So then I am done to question. So what was the third question? The peak current. So how I will get that one? So what I am doing first, I am writing S equal to VRMS multiplied by IRMS, meaning that everybody look, because my apparent power was given, which is 12 kVA, what is the meaning of this one? This is multiplication of VRMS IRMS. So that I am writing S equal to VRMS IRMS. From here, I am plugging the number of S, 12 kVA, equals to, what is my VRMS? That is 120 volt. That was given in the problem. You see, from a 120 volt RMS sinusoidal source. So therefore its angle is not given, meaning that its phase angle is 0 degree. So just 120 volt, but of course clearly mentioned this is RMS. So therefore 120 volt multiplied by IRMS. So from there I am calculating IRMS. So 12 kVA over 120, I got 100 ampere. So keep in mind that is the RMS value. But the question was, look, find out the peak current. Peak current. Peak means that is not the RMS, that is not the effective. Peak is the amplitude. So therefore, look, what is the peak current? This IRMS multiplied by root 2. That we have learned. So then I got the result 141.42 ampere. I am done. So the last question was, find out the load impedance, G value. So therefore see, what is the load impedance G? VRMS over IRMS. So what is my VRMS? My VRMS is 120. What is my IRMS? Which is 100. And then I want to express in complex format. So I need the angle. How I get the angle? Directly the power factor angle. This one. This angle. Cosine theta. Because you remember we discussed the impedance triangle similar to this one. In case of the impedance, R is here, X is here, G is here. Therefore, the G angle, that is also exactly the same thing. I mean, you will get exactly the same result, same power factor. That's why power factor angle, which is 31.13, directly that is the angle of the G. So I got like 1.2 angle that on ohm. So I am done. Everybody, could you follow me? This one?
Yes.
Yeah.
Any question?
Just got to practice it.
Yeah, sure. Yeah. Everybody, like during the class, so of course, although I am not seeing you, I am not looking you, but I am assuming that each of you are using your pen and paper, and you must have calculator with me. So therefore, you will be doing. And then again, later you will be looking, plus again, you will be looking the video to get the explanation. And then again, in addition, in case any of you have any questions, confusion, you could email me. I will be glad to answer you anytime. I mean, just feel free. I mean, don't hesitate. Don't hesitate to ask me any questions. So, is everybody fine?
Yeah.
Yeah. So please just look carefully, then you will be getting it. Yeah. Everything. I mean, by now, I think you all are understanding everything, the relationship of, frequently, like you need to draw this triangle, and frequently you need to draw that impedance triangle, impedance calculation, power factor calculation, real reactive power. These are all, I mean, in AC circuit. Okay, so I assume that you all understood. So I'm stop sharing. Does anybody have any